Excellent. Hey, great to talk to you today. Also want to let you know that Anup Patel and Stefan Duda of Apex.AI are on the chat. So for Q&A, any questions about what Apex.AI is doing on this, they can help with that as well. So myself, Joe Speed, I think most of you probably know me by now, been involved with the SOAFEE for some time, and really in my involvement in this, Girish had this idea of what if we could do Cassini on wheels, but you needed a development platform. Like, how do you get parity with the vehicles? And this thing that Linus said really struck home for me about cross development's pointless and stupid when you can just develop, deploy on the same platform. And that seemed to be a key thing that was missing here. And so for the native parity, for developer productivity, so what's going on, right? The vehicles are moving to multi-core ARM. The EE architecture is changing, so perhaps the development environment should too. And, we talk about these being cloud-native software-defined vehicle, so maybe they need a cloud-native DevOps. So, there's a lot of us that have believed for some time that there's value in having native parity end-to-end of basically getting, if the car is an ARM architecture and you work all the way back upstream from that, how do we get all of these things onto the same architecture, and what's some of the value of that? And for Apex.AI, just want to share a little bit of perspective from them. You've got the software and platform complexities are increasing as we move to software-defined vehicle. And you've got challenges around these heterogeneous platforms, many different RTOS and different test strategies, and constant requirement changes. And the result is that all of this complexity is slowing down the development process, right? So it delays validation to this very late stage where you get this kind of big bang integration. And so, moving to native parity doesn't solve all of this, but it helps address a certain swath of pains. And so if you look at, as an example, what Apex.AI has implemented for their CI/CD DevOps, that you see the CI/CD server with the Graviton, ECU farms, you see doing all the QNX QEMU, so virtualized emulated ARM instances running on Ampere Ultra servers there on premise, working with the cloud, the developers with the MacBooks, with the Apple Silicon, with the Ampere Ultra dev platform, all of this able to give them parity end-to-end there. And so the build quality, time, energy that uses. So, ARM architectures like Ampere offers with the Ultra Max, and AWS Graviton, they do well with workloads that scale. So the compilation scales great. But the linking, this has been kind of a weak part in the past, that linking didn't parallelize well, so it favored having a small number of fast cores. There is relief though, right? So things like Mold from the author of the LLVM linker, it's highly parallelized, built into GCC 12, works with others. And so for Apex.AI, what they've done is move from a default of cross-compilation to a default of native compilation. And some things result from that in terms of the ease of use, testing on target, no longer needing sysroot, all of these kinds of things. And if you look at the test quality and the time and the energy use for that, you get more accurate CI testing by having an architecture that resembles the ECU, right? So testing and emulation on x86 can miss some issues. And you also get faster CI testing by eliminating this emulation on x86 platforms. And so Apex.AI's own experience, fully automated build to deploy, test on ECUs and R&D vehicles. They're running tens of thousands of unit tests. Test on cloud, followed by testing on-premise virtual and physical ECUs, and being able to run many virtual ECUs on these, kind of cloud-native platforms like Ampere Ultra to run unit test in parallel, So the ease of use becomes improved, testing on target becomes simpler. And so wanted to show you a little bit of testing that Samir, Rajiv, Raul at Ampere have done. So using a Cortex A72 ARM64 QEMU emulator and then running these example test workload on a x86 and running it on ARM64. And what they observed is that running an ARM emulator on ARM, you get a lot more throughput. And a corresponding reduction in your energy use, so your carbon footprint for all of this. Then they thought well, what if we run that same workload as containers and as QEMU ARM with the KVM, okay, as VMs instead of emulators? And that result was actually surprising to us. So, in my head, I was expecting, 5x, 10x improvement, not necessarily 100x improvement on test throughput compared to where we started from. So this has big implications. Think about like developer productivity. If you can get through your test faster, you can do more tests. If you can get through it on a more accurate platform, the quality of the test is better, and you can reduce the carbon footprint of your DevOps environment. And eliminating cross-compilation, right? If you're able to use the system tools, the things that are built in, these get the most work, they get the most frequent updates. Cross-compilation is great, but certainly cross-platform debugging is a real bugaboo. And at Apex.AI, Apex, just to be clear, they're expert at cross-compilation. They know this cold, but native is easier, and there's value in having it be easier. So simplify the tool chain, can use the native tool chain. Adding packages takes less time. It's easier to get the dependencies right. The automation is now easier, and it's more easy to test the natively compiled binaries on the host and on the target. And ending the cross-platform debugging, right? So, setting up the environment for GDB is easier. You can use the native tools to investigate the target binaries, and you simplify the CI pipeline. So at Apex.AI, this has really simplified their setting up of CI instances, reduce the overhead for the DevOps team, and the like. And so one of the comments from Anup was, life at Apex.AI is better for the developers, the DevOps teams, the test team, since moving to to a native parity environment. So how can you get started here, right? So, think about things like leveraging multi-architecture, Kubernetes, OpenShift, right? So that you can have your core of your pipeline be with native parity, but still able to incorporate your legacy x86 tools, okay? The other things in your tool chain that are not yet supporting that. You can get to native parity using tools that support it, right? So things like Apex OS, Apex middleware, where you can go from a Ampere Ultra workstation or a MacBook all the way through to a target vehicle and stay on that native parity all the way end to end. And the solutions available for that, right? From a dozen computer makers, bare metal providers, and clouds, right? So people like our friends at AWS, the Google Cloud, the Azure Cloud, the Oracle Cloud, Equinix, Tencent, all of these, right? And here are some examples of things. So, right, for everything from a developer platform, a workstation, to a build server, to being able to do an entire DevOps farm in a single 2U box, being able to collapse all of your MLOps and simulation into a single server. So everyone to the big tent, right? There's much that we can do here. Ampere and Apex.AI will work to improve the SOAFEE developer experience. Tooling's an area where we can all work together. There's still a lot to be solved. So how to simulate the data buses, physical network elements, QNX and other native integration in the cloud. And I know Justin and crew are working on those things. How to incorporate the hardware accelerators, the things that are specific to the vehicle, and bring those into the testing further upstream. And just wanted to thank a bunch of folks that have been working with us, with me around this area for some time. And so thank you for that.
Thank you, Joe. Another interesting view of the world where we're looking at this parity between what happens in the cloud and what happens in at the edge. And again, this is all down to helping accelerating the development of software-defined vehicles. So I appreciate that, Joe.